Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own Mass Coder this side. So I'm starting off with a new playlist on binary trees, a much demanded topic in the placement industry. Okay, so you have to get much familiar with this topic, this and BST, which we will be discussing just after this, right? To get into the industry, to clear your OAs, right? Because binary tree is a very important topic, right? And it is a bit tricky because almost all the questions are always solved through the recursion, so you should have a somewhat understanding. I'm not saying mastery of recursion, but yes, a somewhat understanding of the recursion gives you an upper edge on the binary trees, right? Okay, so let us start with it. Believe me, if you will follow along with this playlist just like the linked list series, you will be able to get through any question of binary trees very easily, right? Very easily. Okay, moving on. Binary trees. So first of all, what is a binary tree? Binary tree, in short form, it is always called as BT, right? Initials. Now, a binary tree, as the name suggests, binary means two, and tree, as you all know, a tree is a much grown plant, right? So, tree, it says that it will have a node. It will have a node. Just as a linked list, it will have a node. It will have a node, right? But now, two means it has two children. It has at most two children. It has at most two children. What do I mean by at most? At most means that 2 is the upper limit, that it can have two children, it can have one children, or it can have zero children. It can have zero children. So the binary tree actually looks something like this. In the circles, you will have to fill the value which you want to keep here, right? This is an example of a binary tree, right? This is an example of a binary tree. Now there are some points to mention. There are some points for the naming convention, right? This first node from which you can see the binary tree is actually emerging out is known as the root. Is known as the root. Okay. Now root, as you can see, root has two children, 1 and 2. This children on the left side is known as left children, left child. This child on the right is known as right child. Now, as you can see, this right child also has two children, 1 and 2. This is the left child of the right child, and this is the right child of this right child. Okay. So the naming convention continues. Now, whenever you encounter a node who does not have, whose left and right, both children are not present, For example, these nodes. This does not have a left child or right child. This does not have a left child or right child. This does not have a left child or right child. Are not present in, that is known as a leaf node. Leaf node. These nodes on the last edge are known as leaf nodes, right? That is, furthermore, the binary tree cannot be expanded down from there because there is no left or right children of these nodes, right? So leaf nodes are actually marking the ending of a binary tree, right? Or ending of a binary tree. Okay, this is actually almost everything about you want to know about binary tree, right? But why do we use it? Why do we use it? Why do we use it? So binary tree is actually a much efficient way of storing data. Efficient way of storing data. How? So I'm not trying to confuse you, but I'm telling you the future only. Binary tree is actually a class. Binary tree is actually a class. There are many subclasses of it. What are the subclasses? It can be a red black tree. It can be a binary search tree. It can be a segment tree as well, right? And each of these trees are part of a binary tree, are the binary trees with some properties. With some properties. But before moving on to any of these, we have to go through binary tree to understand what is the data structure representing and how can we solve the problems. Believe me, if you have got a tight grasp on the binary trees data structure, all these topics, which are actually like binary search tree is actually for the DSA preparation, but red black tree and segment trees are actually the part of the competitive programming. Believe me, if you get a grasp of binary tree, these all the trees, suppose B plus trees are also an example, B minus trees are also there, AVL trees are also there. Every one of them, each one of them will be very easy for you to understand if you get binary tree concept tightly grasped in your hand, right? Tightly grasped in your hand. And for that, you will have to follow this playlist. It will comprise around 40 videos, and the videos I will try to keep it edited at maximum 20 minutes, 25 minutes of time. And believe me, if you complete this 40 videos serially, believe me, you will be able to solve every question, whether that is lead code easy, lead code medium, lead code hard. Easy, medium, hard, all will be on the tip of your hands because we're going to practice a lot. Okay. Now, it is time for us to see that why do we need the binary trees? As I explained, to follow these trees, right? Now, binary search tree, what does binary search tree do? It actually helps us to find values faster, For example, you have an array which is 1, 2, 4, 5, right? And you want to find 3 in it, whether 3 is present or not, whether 3 is present or not, So you will have to do a linear search, right? You will have to do a linear search. But we already know about binary search. So what does binary search do? It sees if the array is sorted, it can, like linear search returns in O of n time and binary search returns in O of log n time, right? It is actually a optimization. Binary search tree also returns in O of log n, right? O of log n. But binary search tree will be a separate playlist, so I will leave that to you right now. I will just be moving towards binary tree. Okay. Now, how do you store this? How do you code it down? How do you code this structure down? As you can see, I have a root node. Each of them contains some value, right? And each of them has a pointer towards left or a right, right? So I'm actually trying to make it familiar with the linked list, right? So in a linked list, you had what do you had in hand? You had two values in each node, right? One is for value and one is for next pointer, right? Something like this was your linked list. Value, next, it was pointing towards his next node. If the next node is not there, it was pointing towards null, right? Similar is with the binary tree, but here the size of the structure will be, size of the node will be somewhat bigger. Why? Because I want to keep two nodes. What does that mean? I will make a node, suppose this is my node. I will keep my data here, whichever I want to store. I want to show 1, 2, any alphabet, any integer, any string, etc. Right? I can store any data. Now, I want to make another node, which is, let us say, data 1. Let us say it is as 1, and let us say it is at 2. Now what? I want to connect this root node to this left and root node to this right. What will I do? These two values are actually going to hold the pointers. So this will actually point towards the address of this. This will actually point towards the address of this. That is, roots left is equals to left. Root left equals to left. And root right equals to right. Root right equals to right. Simple. What will my structure look like? I will declare a struct node, right? What will happen? First value is for data. Inside, instead of int, you can keep it as any other value also. You can keep a char, you can keep a string, anything you want. Int data. Moving on, what do? You say, like you say that the structure, this structure is actually similar to this structure, right? The structure is similar, right? So I will say it will keep a pointer. For pointer, I will use a star. Name it as left. This left will store the left child for the left child. That is this one, right? And similarly, I will keep a node star right? And this one is for right child. That is this one, right? Now, whenever the new node I have to make, what will I do? I will just make a constructor of this. Suppose I get the data 1. Now, implementation goes like this in the conventional way, that I will only receive my data 1 and I will say data equals to data 1 and both the left and right child are null. And then in the main function, I actually combine, like left and right child are initialized with null. And whenever I want to make a connection, I do it through the driver function. But if you want something else, you can also do that. Like you can send left 1 here and then you can send the left node exactly and it will be left 1, right? Etc. etc. That is up to you. That is simple programming, right? If you are familiar with the structs, then it is very easy, right? I just wanted to tell you that it will look something like this. Int data, it will hold a data, hold the pointer to the left child, hold the pointer to the right child, right? This is only important in the case of binary tree. This is the actual implementation. I will be coding it on the VS Code, so don't worry about it, right? Now, I want to tell you about the operations. So operations are similar to the linked list only. Why I'm telling you linked list? Because linked list actually gives you the idea of how to deal with the pointers, right? Because it also contains next and it is a very easy data structure. So if you're well versed in linked list, then binary trees also becomes easy for you because you know about the pointers, right? Now what are the number of operations? Similar to linked list, insertion, that is insert any node, right? Deletion, delete any node. The third thing here is searching. Not specific to binary tree, but yes, you can search a value in the binary tree as well. But the most important thing is traversal. Now what is a traversal? As in the linked list, you were traversing all the parts, right? So, but the linked list was actually easy. Linked list was looking something like this. This pointer, this pointer. So you know that you have to travel this one. Suppose 1, 2, 3 are the values here. This is pointing to null. So traversal means 1, 2, 3. But binary tree is actually something like this. Suppose I say it is a root tile, it is left and it is right, right? Suppose this is root. Now there are actually many types of traversal. What are the types of traversal I am saying? I can say that what if I visit my root first, that in the vector of the traversal I can say that it is I will take my root first, then I will go towards left and then I will go towards right, right? I can do something like root, then left, then right. I can also go through left, root, right. I want my left child first, then my root, then my right. Or I can also go through left, right, root. Like there are millions of, like not millions exactly, but there are many traversals possible. So traversal is an important topic which will be dealt through some videos, not only one but 3 videos specifically for the traversals. So please hold back your horses, because traversal is all gonna be important topic which we'll be discussing in the next video itself. Traversal is the first topic which we'll be learning in the case of binary tree, right? Okay, so what did we discuss up till now? We discussed the need of binary tree, need of BT, implementation of BT, and third thing, operations of BT. Operations of BT. Believe me, up until now, these are the only things you want to know. There is also a topic of types of BT. Types of BT. But believe me, I'm not telling it, I'm not teaching it, because first of all, it is very easy. And no one asks this, and no one asks this, and neither it is of your importance. It is also not of your importance. Whichever will be your importance, I will be teaching you subsequently in the upcoming videos as well. Okay, now let us see the VS Code implementation. Like how do we make a node, right? Only that's all. Okay, so let us move to the VS Code now. So as you can see, I've already written the code for you. You can see the code of the binary tree node. I have created a data, I have created a left node, I have created a pointer to the right node. Whenever I call the constructor, data will be assigned to the data one, and left equals to null, right equals to null. How will I make a node? So suppose I want to make a node star, let us name it as root. What will I do? I will create a new node. Let us call this value as 1. I want to pass one value to my root. Now I want to create a left child. So root left equals to new node, and let us say I want to fill the value 2 there. Root right equals to new node, let us say I want to fill a value 3 there, right? Now you should be able to print it also, right? So C out root data and del. Let us see if it works, right? It should work. I should not give any error, I guess. See, it is printing 1 because root data we stored 1. I can also print the root left data. Let us try to print it. Oh, typing mistake, sorry. Let me try to print it, right? Run code. You can see it will print 2. It is printing 2. And similarly, you can print the right data. Right data. Right? It should work, I guess. Yeah, it is working. It is not the limitation that only you can go up till left and right. You can also go up further. That is, I can also make something like this. Right of right. I can also make right of left of right, sorry. Like something like this, and I will say it is the node 5. And I can just carry down here that right of left, that is root. This will go to the root. This will take me to the right part of it. This will give me the left part of the right node. And then I will print its data. So that if I print it, it should print 5. I guess it will work. And it is printing 5. So this is the implementation of VS Code of the binary tree. So I guess it was very much clear to you. It is nothing to be scared about. And believe me, please follow this playlist. I cannot request you enough. This is not going to be a long playlist. I hope that if you will pay some attention each day, binary tree is a very easy and a cake work for you. Okay, so I will be signing off now, but please meet me in the next video itself.